objectives for today's topic. So we have the following. Okay, this will be the objectives for today's topic. Okay, so electrostatic electricity. So it is also known as electrostatic. So electrostatic or static electricity uh, focuses on the charges or the on atoms and its parts and the charges of these particles. So since we are talking about atoms, so first, alamin natin kung ano ba yung parts ng atom. So I think you're already familiar with the parts of atom and their charges. Okay, so first we have the protons. Okay, protons. So protons are the positively charged particles. So it carries positive charge. Then we also have the neutrons, which is neutral. So since it is neutral, so it has it is neither positive nor negative charge. Since neutrons is a neutral charge. And last is the electrons. Okay, electrons is the negatively charged particle, so it carries a negative charge. So these are the parts of atoms and the charges they carry. So first we have the protons, which carries a positive charge. Then we also have electrons which carries a negative charge. And last is the neutrons, which is a neutral. So it neither positive nor negative. So these three parts or these parts of atom, okay, are the different parts of atom and its charges. So the the unit, okay, the unit for these charges of atom is in coulomb. Coulomb with a symbol capital letter C, okay, and these are the mass and the charges of each subatomic particles or each part of atom. So for the proton, okay, so for the proton, we have its mass, which is 1.67 times 10 to the power of negative 27 kilogram. So ito yung mass ng ating proton. And the charge it carries, so it is a positive 1.602 times 10 to the power of negative 19 coulomb. So ito yung ating charge ng proton. And for the neutron, okay, neutron and proton are equal. So they are the same in mass. So magkakalaki sila and they have the same mass. So for neutron, the mass of our neutron is the same with our proton, which is 1.67 times 10 to the power of negative 27 kilogram. But okay, the difference between neutron and proton, so they have different charges. So since proton has a positive 1.0602 times 10 to the power of negative 19 coulomb, yung neutron naman, so since it is neutral, so therefore, it is equal to 0 coulomb. So since neutral siya, so it has no charge, so it doesn't carry any charge. So since it is neutral. And ang pinakamaliit among the three, okay, yung pinakamaliit is yung electron. Electron, which is the smallest among the three, which has a mass of 9.11 times 10 to the power of negative 31. Okay, electron is the smallest among the three, which has a mass of 9.11 times 10 to the power of negative 31 kilogram, and it carries a charge which is equal to 1.602 times 10 to the power of negative 19. And since electron carries a negative charge, so the charge of electron is in negative 1.602. So these are the parts of an atom, okay? With these three subatomic particles, ito yung bumubuo sa isang atom. Okay, so ito yung bumubuo sa isang atom. So an atom has protons, it also has neutron and an electron. So with these three subatomic particles, so it creates atom. And these are their masses and also the charge they are carrying. Okay, so these are the parts of an atom, which we call as the subatomic particles. So the these charges, okay, so these these subatomic particles may flow or it doesn't flow in a material. So it depends on a material. There are some materials that these three particles or these subatomic particles can flow, and there are also some materials which these three particles cannot flow. So hindi silang lahat ang pwede maka-flow, and there are also some materials that the three subatomic particles can flow, and that these are the conductors materials and the insulator materials. So what is the difference between a conductor and an insulator? So when we say conductors, okay, conductor materials, so these are materials that allows charges to move freely. Okay, it allows charges to move freely. So those subatomic particles with charges, so they are allowed to flow, okay, to flow in a conductor substance. And in the insulator substance, okay, so in an insulator substance, these subatomic particles which has charges, so they are not allowed, okay, they are not allowed to move freely in the insulator substance. Okay, so in a conductor substances, so they can move freely. So these charges can move freely. But for insulators, they are not allowed to move freely. So they cannot penetrate or they can move through it in the insulator substance. A best example of a conductor and insulator is, if you can see, I think if you cut a wire, okay, if you cut a wire, any wire, so pwede yung sa charger, yung sa appliances, or even yung sa bulbs, so any wire, so a wire has both conductor substance and an insulator substance. Conductor, an example of conductor substance is yung if you cut a wire, inside the wire there is a metal, which is commonly they are using copper, or commonly they are using copper. Okay, the copper is an example of a conductor. So in this copper, so dito sa copper, okay, subatomic particles which has a charge moves freely inside those copper. So dun sa copper, yung subatomic particles with charges, so it moves to the copper. And this copper, okay, this copper is wrapped by a rubber. So it is wrapped by a rubber so that this rubber may serve as an insulator, okay, this rubber may serve as an insulator, okay, to block this substance, okay, to block this substance to move outside the copper. Okay? So why do we have to block these charges to move outside copper? It's because um, if you touch the copper, which has a flowing charges, um, then these charges may flow to your body. Since our body is composed of water, and water is a good conductor, okay? Water is a good conductor. So these charges may cause us to be tawag nito, yung kumbaga makukuryentehan tayo, okay? So this electricity will flow to our body, okay, which cause us to be burned. Okay, so that's why this wire is being wrapped by an insulator, which is a rubber, okay, so that it will not flow outside the copper. So another example of conductors, okay, so we have metal. So we also have water, okay, our body. So these are a good conductor of electricity. So for insulator, so we have rubber, we have wood, and other type of insulators. So that is the difference between a conductor and an insulator. So I repeat, conductor allows charges to move freely, and insulators doesn't allow charges to move through it. Okay, so that is the conductor and insulator. So the triboelectric series. So the triboelectric series. So this it is a list, okay, a list that ranks, okay, it ranks materials according to their tendency to gain or lose electron. So there are some substances, okay, there are some substances where if you rub these substances, the substance A, okay, for example, if we rub substance A and substance B, okay, so if we rub these two substances, there are substances that loses electrons and the other gain those electrons. For example, for substance A and substance B, okay, in the triboelectric series, in this rank, for example, the human hand and the Teflon, okay, so if we rub our hand to a Teflon, then our hand, so since human hands, okay, is at the top, okay, at the top of the rank, so it tend to lose electrons, so it will lose electrons, and since Teflon is on the bottom of the rank, then it will gain electron. So the electron loses from the human hands will be transferred to the Teflon since it tend to gain electron. And this process is what we call as the triboelectric charging. Okay? This process is what we call as the triboelectric charging. So if we rub our hand to a Teflon, then the electrons on our hand will be transferred to the Teflon, okay, since our hand loses electrons and the Teflon gain those electrons, and that is what we call as the triboelectric charging. Another example of a triboelectric charging is when you rub a rubber rod into a 4. Okay, if you rub a rubber rod, for example, if you have a rubber rod Then you rub this into a fur. Okay. Then the electrons are removed from the fur and deposited on the rod. So it will be transferred from the fur into the rod. Okay, so the the electrons from the fur will be transferred to the rod. So since electrons lang yung matatransfer, okay, then those negatively charged particles, yun lang yung matatransfer. But the positively charged and the neutral charge will remain on the fur. So ang matatransfer lang is yung negatively charged particles. But other than that, the positively charged and the neutral charge, they will be remained on the fur. And this is what we call as the triboelectric charging. So in the triboelectric series, okay, in the triboelectric series or in this rank, so there are these are only an example. Okay, these are only an example. This is only an example of a list of materials which is ranked according to their tendency to lose or their tendency to weight, to gain. So there are some. There are also some example of ranks, okay, or some materials, okay, but for this time, these are the only materials that I can give you, since if ibibigay ko lahat, so siguro kukulangin ang isa or dalawang slide. So if you wanted to know the some materials that is ranked according to their tendency to lose or gain electrons, so you can search it online. Okay, just search it, Triboelectric series. So there are some list, okay, list that is being ranks the materials according to their tendency to gain or lose electrons. Okay, so that is the Triboelectric series. Okay, so the first law of electrostatics. So the first law of electrostatics, it states that like charges repel and unlike charges attract. So this is the reason why is it that so this is the explanation why is it that there are some magnets, okay, there are some magnets which um, um, which attracts one another, okay, which attracts one another, na kahit pa ilang beses mo silang ipaglalayo, then they will eventually attracts one another. So kahit ilang beses mo silang ipaglayo, then magdidikit pa rin sila. And there are also some magnet na kahit anong pilit mong pagdidikit, hindi talaga sila magdidikit. It is because that magnet could be has a like charges, or they could have unlike charges. So if they have like charges, okay, for example, if they are both positive, then they will repel each other. So kahit anong pilit mong pagdidikit sa dalawa, hindi talaga sila magdidikit since they have like charges. But if they have unlike charges, or they are unlike charges, if they are negative and positive, then kahit anong kahit anong paglayo mo sa kanilang dalawa, magdidikit talaga sila since they attracts each other. Okay? So for like charges, they will repel each other. For example, if they are both positive or they are both negative, then they will repel each other. But if they are unlike charges, if they are negative and positive, then they will attract each other. So that is the first law of electrostatics, which state that like charges repel and unlike charges attract. And this is the reason, okay, The first law of electrostatics is the explanation is also the explanation for the polarization of charges. So ano ba itong polarization of charges? Okay, polarization charges occurs when an electric field distorts the negative cloud of electrons around positive atomic nuclei in a direction opposite the field. So this polarization of charges has a slight separation of charge, makes one side of the atom somewhat positive and the opposite side somewhat negative. So in the polarization of charges, for example, in this sphere, okay, in this sphere, um, if wala pa itong rod, if rod is not around, okay, if ilalayo mo itong rod, then the 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 particles inside this sphere, okay, so kakalat yung kanilang particles. So there are some positively charged in the left side, there are also some in the right side, some in the middle, on the top, and there are also, and the negatively charged particles are also distributed in the sphere. So there are negative in the right, negative in the left. So it surrounds the neutral conducting sphere. Pero pag ilalapit mo itong positively charged glass rod, okay? Once na ilalapit mo itong positively charged glass rod, so since positive siya, so since positive charge siya, then those particles which are positively charged, okay, will be repelled, okay? So i-repel niya yung positively charged particles and it will attract the negatively charged particles. So that's why it makes or it creates a slight separation of charge. Okay? So it creates a slight separation of charge, which makes one side of positive charge and a one side of negative charge. It is because these positively charged, itong mga positively charged particles is being repelled by the positively charged glass rod. And these negatively charged particles is being attracted by the positively charged glass rod. So that is the polarization of charges. So the distribution, okay, the distribution of positive and negatively charged subatomic particles, okay, will be distorted when there is a positively charged materials na ilalapit mo dun sa kanyang sphere. So that is the polarization of charges. So since atom has a subatomic particle and it has charges, okay, so these subatomic particles and its charges was discovered by Sir Charles Coulomb, okay. So these subatomic particles and its charges was discovered by Sir Charles Coulomb or Charles Augustin de Coulomb. So he is a French military engineer and a physicist from France during 1736 to 1806. And based on this observation, okay, based on this observation, he developed an equation. Okay, he developed an equation which is equal to which is the Coulomb's law, which is F is equal to K times Q sub 1 times Q sub 2 over R square, where F is the force in Newton, K is a constant, so it is equal to 9 times 10 to the power of 9 Newton times square of its meter divided by square of its coulomb. Then Q sub 1 and Q sub 2, these are the charges of particles. So Q sub 1 is particle A and Q sub 2 is particle B. So in the Coulomb's law, so we have two particles, which is the Q sub 1 and the Q sub 2. And the charges of these particles, okay, which is in column, is the value of our Q sub 1 and Q sub 2. R, okay, R is the distance between these two particles, okay? R is the distance between these two particles, which is in meters. So, Coulomb's law, so we have force is equal to constant times charge of Q sub 1 times charge of Q sub 2 divided by the square of its distance. So this is the equation developed by Sir Charles Coulomb based on his observation on the particles, on the subatomic particles of the atom. Okay? So try natin to use this equation in a given problem. So how far apart, okay, how far apart are two charges, one of magnitude 3 microcoulomb and the other of magnitude 5 microcoulomb? If the force between them is 20 Newton. So since we are looking for the far apart, so we are looking, or we are referring to the distance of the two particles. So the first particle, it has a charge of 3 microcoulomb. So ito yung ating Q sub 1, which is a charge of 3 microcoulomb. And the second particle, it has a charge of 5 microcoulombs. Ito yung ating Q sub 2. So if the force between them, okay, if the force between them is 20 Newton, so ito yung ating F. So this is the force between the two subatomic particles. So using the equation of Coulomb's law, so using Coulomb's law, K is equal to 9 times 10 to the power of 9 Newton times square meter over square coulomb. Force is 20 Newton. Q sub 1 is 3 microcoulomb and Q sub 2 is 5 microcoulomb. Then we are looking for the distance. So since our coulomb is in micro, so convert natin siya into coulomb. And micro, so since micro is equal to the 10 to the power of negative 6, so convert natin micro to 10 to the power of negative 6. So that is 3 times 10 to the power of negative 6 coulomb. 5 microcoulomb is equal to 5 times 10 to the power of negative 6 coulomb. Okay, so our force is now in Newton. So constant, it is already given. Q sub 1 and Q sub 2 is in coulomb. So now we can solve for the distance. So to solve for the distance, so substitute lang natin. So 3 times 10 to the power of negative 6 times 5 times 10 to the power of negative 6, that is equal to 1.5 times 10 to the power of negative 11 square coulomb. So cancel yung square coulomb. Then multiply 9 times 10 to the power of 9 times 1.5 times 10 to the power of negative 11. And that results to 0.135 Newton times square meters. So since yung hinahanap natin is si R, so lipat natin siya sa kabila. Then si 20, lipat din natin sa right side. So that is equal to R square is equal to 0.135 Newton times square meter divided by 20 Newton. Okay. So continue natin. Next, cancel natin itong Newton. Then 0.135 divided by 20, that is 6.75 times 10 to the power of negative 3. So since naka-square yung ating R, So square root natin both side. So cancel yung square. Then square ng meter. So square root of 675, that is 0.08215838363 meters. And since the least number is only 1, so we will round this to one significant figure. And that is equal to 0.08 meters. And that is the distance between the two particles. A positive 10 microcoulomb point charge is 25 centimeters away from negative 20 microcoulomb point charge. So calculate the magnitude of the electric field between them. So the electric field, so itong electric field, so it is referring to the force. Okay, the electric field is referring to the force between the two particles. So the positive and negative charge, okay, this positive and negative charge, so it is an indicator, okay, it is an indicator. So if what type of subatomic particles they are. So since positive 10 is positive, so therefore it is a proton, and negative 20 is an electron. So ito yung ating Q sub 1, which is the charge of our first particle, and our Q sub 2, which is the charge of our second particle. But the positive and negative, so we will use the absolute value of our charges. So gagamitin natin yung absolute value ng kanyang charges. So regardless of its sign, as I have said, it is an indicator of what type of subatomic particle it is. So the distance between the proton and the electron is 25 centimeters away from one another. So ito yung ating distance. So using this and the equation on Coulomb's law, so solve natin si force. Okay, so since ang ating Q sub 1 and Q sub 2 is in micro, so convert natin siya into coulomb. So that is 10 microcoulomb is 10 times 10 to the power of negative 6, and 20 is 20 times 10 to the power of negative 6. And since our radius, our distance is in centimeters, so convert natin siya into meter by multiplying 1 meter over 100 centimeters. So cancel yung centimeters. Then 25 divided by 100, that is 0.25 meters. So since it is already converted, so substitute na natin. Then simplify 10 times 20, that is equal to 2 times 10 to the power of negative 10 square coulomb. Then 0.25 square, so that is 0.625 square meters. Then 9 times 10 to the power of 9 times 2 times 10 to the power of negative 10, that is 1.8. So cancel yung square coulomb. Paiwan na lang is in Newton times square meters. So kung cancel yung square meters, so 1.8 divided by 0.0625, that is 28.8. So since the least number is only 1, so rounded to one significant figure, and that results to 30 Newton. So the electric field. So electric field, ito yung force. Okay, this is the force. So electric field is a force field that surrounds an electric charge or group of charges. So this electric field, okay, this electric field is it is a force that surrounds proton. Okay, it is a field. It is a force that surrounds protons. Okay, it surrounds the proton, which makes the makes the electron, okay, which separates the electron from the proton. So this electric field separates the electron into the proton. But since electron is a negatively charged particle and proton is a positively charged particle, so they will attract one another. And because of electric field, okay, because of electric field that separate these two particles, okay, so because of electric field that separate these two particles, so yung electron which is being attracted to the proton, so ito ay it will since hindi siya makapasok dun sa electric field, so ito ay iikot, okay? It will revolve around the proton, okay? It will revolve around the proton since there is an electric field that separates the electron and the proton. Okay? So since there is an electric field that separates the electron and the proton, but they are attracted to one another, so this electron, okay, this electron is being moved, okay, it will revolve around the proton, okay, because of the force of attraction to the proton. So since mas malakas yung force on the electric field, the force of attraction in the electron, okay, because of the force of the attraction of the electron, it caused the electron to move or to revolve around the electric field. So it is just like a satellite, okay? It's just like a satellite in a planet. So since yung satellite is hindi siya makalapit dun sa planet, so that's why a satellite will constantly revolve around the planet. Okay? So the satellite will constantly revolve around the planet. So this illustration, okay, is also is an example of an illustration on the electron and proton. So since hindi makalapit yung electron to the proton, and as it is being attracted to the proton, so it will only revolve around the proton since they are being separated by the electric field. And with this, electric field has an equation. Okay, electric field has an equation. So it has both magnitude and direction. And the direction of an electric field at any point by convention is the direction of the electrical force on a small positive test. So charge placed at that point. So yung kanyang direction, it is the same direction of the small positive test charge placed at that point. So the electric field has to be able to know the force or the magnitude of the electric field, so we will use the equation for electric field intensity. So the electric field intensity, okay, using the electric field intensity, we can be able to identify the strength or the force of the electric field. So we have, so in electric field intensity, we have two equations. So first, we have E, okay, electric field is equal to the force divided by the positively test particle. Then E, or electric field, is equal to the constant. Okay, constant is equal to particle charge of the particle divided by the square of its distance. So E, electric field strength, which has a unit of N over C. Then Q test is the positive charge, test charge, which is in column. Q is the charge producing field, which is in column. R is the distance. F is the electric force, which is in Newton. And K sub C is the column constant. So using these equations, we can be able to identify the force, okay, the force or the strength of the electric field. So in using this equation, okay, so choosing among which of this equation is to be used, so we need to know which of them is appropriate to the given. So if yung given is yung force at yung kanyang test charge, then we will use F over Q sub test. But if yung given is its distance and the charge of the charge producing field, then we will use K sub C times Q over square of its R. So try natin in a given problem. So what is the electric field at a point 0.20 meters away from a charge of 4 microcoulomb? So we are looking for the electric field, which is the E. If the distance is 20 meters, ito yung ating distance, and the charge, or ating Q, is 4 microcoulomb. So using this, the equation E is equal to K sub C times Q over R square. So E is the unknown, K sub C, or the constant, is 9 times 10 to the power of 9. Q is 4 microcoulomb and R is 0.20 meters. So since our Q is in microcoulomb, convert natin siya into coulomb. So 4 times 10 to the power of negative 6 coulomb. Then substitute. So cancel yung isang C. And then simplify. 4 times 10 to the power of negative 6. K over 0.20 square meter times 9 times 10 to the power of 9. So 0.20, that is 0.4 square meter. So 4 times 10 to the power of negative 6 divided by 0.4, that is 1 times 10 to the power of negative 5. So cancel yung square meters. The next, multiply 9 times 10 to the power of 9 times 1 times 10 to the power of negative 5. That is 90,000 N over C. And since the least number is 1 and 90,000 is already one significant figure, so our final answer is 90,000 N over C. Okay, next example. Okay, how far from a point of charge 90 nanocoulomb will the field intensity be 500 Newton per coulomb? So in this case, we are looking for the distance with a charge of 90 nanocoulomb. So ito yung ating Q. And our field or our okay, the electric field is 500 Newton per coulomb. So since we are looking for the value of our R, so we will use the equation E is equal to K sub C, Q times R square. R yung hinahanap natin, so K is 9 times 10 to the power of 9. Q is 90 nanocoulomb and E is 500 Newton per coulomb. So nano is equal to 10 to the power of 9, 10 to the power of negative 9. So convert natin 90 to 90 times 10 to the power of negative 9 coulomb. Okay, the next, substitute. So cancel pa rin yung coulomb. Then multiply 9 times 10 to the power of negative 9 times 9 times 10 to the power of 9. And that is 810 nano times square meter over coulomb. So since si R yung hinahanap natin, so transfer natin siya sa kabila. And yung 500, transfer rin natin sa kabila. Okay. Okay, so continue natin. Next slide. So cancel yung nano at cancel yung newton and the coulomb. So 810 divided by 500, that is 1.62 square meters. Then since naka-square yung R, apply natin square root both side. So cancel yung square root. Then yung square root. Then square root of 1.62, that is 1.27279206 meter. And since the least number is 1, so we'll round this to one significant figure, and that is 1 meter. And that is the distance, okay? That is the distance of the positive charge of the charge on the electric field 500 Newton per coulomb.